In our last lesson, we saw how to use the binomial theorem to multiply out powers of binomials. In this lesson, we're going to see why understanding why the binomial theorem is true can save us a lot of work. We like saving ourselves a lot of work. Here's the problem. All right, we're going to find the x to the 6th term of a 1 minus 3x squared quantity raised to the 7th power. So we're going to take this whole quantity, raise it up to the 7th power. Now we could use the binomial theorem. Write out the theorem, crank it out. Multiply out, do a whole board, erase the board, do another board, then another board of algebra to finally get the whole expansion of this. And then we just pick off the x to the 6th term. Doesn't sound like fun, does it? No. Yeah, I'm a little lazy too. I want to find a faster way to do this because I don't want to go through all that algebra. Now I do know what will happen when I multiply this out. I'll get a bunch of terms, and I know where those terms come from. They come from, well, if I write this out 7 times, and I take each possible combination of taking either a 1 or a minus 3x squared from each of those 7 terms. So when I think about that, I realize I'm going to get an x to the 6th term when I take this minus 3x squared 3 times. If I take 3 of these and then take 1 all the rest of the time, I'm going to have minus 3x squared cubed, and that'll give me an x to the 6th. Alright, so we know to make an x to the 6th term, I'm going to have to take my minus 3x squared. When I write out 7 of these 1 minus 3x squareds and I start multiplying them out, I'm going to have to take minus 3x squared 3 times. Which means I'm going to have to take 1 all the other times, and there's 7 binomials, minus 3. That means I'm going to have to take the 1 4 times. Now, how many different ways can I do this? If I take, again, 7 of these binomials, laid them all out, and I'm going to pick 3 minus 3x squareds from those 7 binomials. I can do that in 7 choose 3 ways, because there's 7 choose 3 ways for me to choose 3 of the binomials to take a minus 3x squared from. Notice I'm very careful to keep this negative sign here. If I left the negative sign out, I might get the wrong answer, I might get my sign wrong. So there it is. That's all we had to do. That's all we had to, I mean, I still have to multiply it out, but this is all we have to do to get straight to our term. We don't have to work out the whole binomial theorem. And just understanding the binomial theorem, understanding why it's true, just saved us a whole lot of work. And we like saving ourselves a whole lot of work. Let's go ahead and multiply this out. 7 times 6 times 5 over 3 times 2 times 1. That's 7 choose 3, 1 to the 4th. That's just 1. Minus 3x squared cubed. And again, we remember that minus sign. And we get minus 27. X squared cubed is x to the 6th. And sure enough, we have that x to the 6th that we want. And then simplifying this, 6 cancels with the 3 and the 2. And we have 35 times negative 27 x to the 6th. All right, do it in your head. It's 35 times negative 27. In your head, put the pencil down, pencil down. You got it? All right, I'm going to show you how I do it. I'm going to show you 2 different ways to do it. And we'll see if we get the same answer. 35 times 27. All right, 30 times 20, 600. 20 times 5, that's 100. Put it with the 600. Now we have 700. 30 times 7, 210. Put that with the 700. That's 910. 5 times 7, 35. Put it with the 910, 945. Or 35 times 27. 31 plus 4, 31 minus 4. You take 31 plus 4, you multiply it by 31 minus 4, you get 31 squared minus 4 squared. 31 squared is 961. 4 squared is 16. 961 minus 16 is 945. And there we go. Remember our minus sign as well. So the x to the 6th term in this expansion is negative 945x to the 6th. And we didn't even have to find all the other terms, which makes us very happy. Let's try another one. Let's try one more. Make sure we have this down. All right, we'll wipe this out. And if we'd multiplied it out, that 1 minus 3x squared to the 7th, we'd only be about 1/4 of the way through right now. But now we're on to the next problem. And here's the next problem. We're going to start this time with 2x squared plus 1 over x raised to the 9th. And what we're going to look for here, we're not going to multiply this out. That's not fun. But what we're going to do is we're going to look for the constant term. If we multiply this out, we're going to get a whole bunch of terms with x's in them. But there's going to be one term that doesn't have an x in it at all. What's that term? Now we could multiply it out. That would work eventually. But instead we'd like to go straight to the term that has no x in it. Now, it's not quite as obvious as it was last time which term that is, how many of these we need to take versus how many of these. So maybe you can figure that out in your head, but just in case you can't, we'll take a look at how just thinking about the binomial theorem will let us figure out which term we need. We know what each term looks like when we expand this out. Each term looks like a bunch of 2x squareds times a bunch of 1 over x's. So what's that a bunch of? We don't know. So we'll give that a variable. We'll call that k. We'll say we take 2x squared, we take k of those. Well, that means we're raising to the 9th here, so if we take k 2x squareds, if we take 2x squared from k of the 9 binomials, that leaves 9 minus k to take the 1 over x from. And how many ways can we do this? How many ways can we choose 2x squared from k of the 9 binomials? Let's just 9 choose k, because there are 9 choose k ways to choose which of the 9 binomials give us the 2x squared. So now, well, this is still just 9 choose k, and then 2x squared to the k, well, that's 2 to the k, and then x to the 2k, and then we raise 1 over x to the 9 minus x, while the 1 is still just 1, but the x is now x to the 9 minus k. But we don't want any x's at all. We're looking for the constant term. So we want the x to the 2k to cancel with the x to the 9 minus k. And now we see how to figure out what k is. All we need is 2k to equal 9 minus k. And we can do that pretty quickly. Add k to both sides. We get 3k equals 9, which tells us that k is 3. And now we know which term we want. And instead of starting over and figuring out what that term is, we already have the formula here. We already know where to put our k. We know that k is 3. So we have 9 choose 3 times 2 cubed is 8 times x to the 6th times 1 over 9 minus 3, 6, 1 over x to the 6th. And there we go, just as planned. The x's cancel out. 9 choose 3 is 9 times 8 times 7 over 3 times 2 times 1. And we have our 8 over here. This leaves 3, 2 cancels with 8, leaves a 4. 3 times 4 is 12. 12 times 7, 84. 84 times 8 is, all right, in your head, let's go. 84 times 8. 8 times 80, 640. 4 times 8, 32. 672. And there we go. Didn't have to multiply it out. Didn't have to go through a whole lot of algebra to get the answer. And once again, just understanding the binomial theorem has saved us a whole lot of pain.